The momentum is given by mass times velocity. The change in momentum will be 2mv. The time taken will be distance divided by speed, that will be 2L over V. The number of collisions per unit time for one molecule is 1 over T, so the frequency of collisions for n molecules will be nv divided by 2L. Average force is change in momentum divided by time, and that will give us n mv squared divided by L. Pressure is force over area, so that will give us mass v squared divided by volume. In reality, all gas molecules are moving in random motion. They have equal probability of moving along x, y, and z axis. The average speed in this direction has to be the same. So the pressure will be 1/3 rho v squared. Okay, additional note, we get Ke equal to 32 nkt. So the kinetic energy of an ideal gas is proportional to its thermodynamic temperature. So this equation unifies mechanics and thermal physics. On the left-hand side, kinetic energy is part of mechanics. On the right-hand side, temperature is part of thermal physics. So this equation says that thermal physics is actually part of mechanics.